Hi, welcome to ICT lectures. So we want to understand what is blockchain technology, right? So ideally, blockchain technology is one of the fastest technology that is actually growing, and people are using it. So I know you understand that blockchain has been used maybe in bitcoins, right? And we have other areas that we need to understand that uses this particular technology. So we are here just to understand what it is and maybe some of the characteristics of this particular blockchain technology. So ideally, before you understand this particular blockchain technology, there are things that you need to do, right? It's important to distinguish between three things. These are commonly muddled up, namely the Bitcoin currency, the specific blockchain, and the idea of what blockchain is. So we need to understand, ideally, what's the difference between a blockchain and a Bitcoin, because mostly people normally confuse the two terms. I want to put it straight that the technology that Bitcoin uses is actually a blockchain, as you're going to see what this particular blockchain consists of. So Bitcoin is just a digital currency, right, that uses the platform for blockchain. We know that the founder of this Bitcoin, actually Nakamoto, this is the person who actually invented the first Bitcoin currency. And this particular Bitcoin currency uses blockchain. So these are two different terminologies. So when you're talking about blockchain, look at it as the holistic technology that actually is being used in different industries, not only with Bitcoin, but you can even use it in healthcare, in education, and so on, right? So that is it. So we can say that blockchain is actually a technology that permits transactions. Now, before you create a block of a block within a blockchain, right? Because when we talk about blockchain, we talk about different blocks being set up or being created. Now, these particular blocks comprises of what we refer to as transactions, right? That needs to be gathered and recorded. We are going to look at a sample, a way of how we can understand how these particular transactions are built. Cryptographically, chains blocks in chronological order. What we mean by this is that when before a particular block is formed or created, there need to be some kind of hash functions, or rather digital signatures that needs to be appended to these particular blocks when they are validated, so that at least we have unique and we have secure blocks. That's what we mean by cryptographically, and allows the resulting ledger, right, to be accessed by different servers. Now, what is a ledger? Normally, we refer to a ledger. We normally have open ledger, closed ledgers. Those are just financial terms. But with respect to blockchain, ledger could actually be those particular compiled transactions, right? So we can have different blocks comprising of different ledgers, right? Again, we need to understand that a blockchain is actually built on top of distributed system, right? A blockchain are normally used not in centralized environment, but they are there to actually help in distributing transactions across different locations and across different nodes, as you're going to see, right? So we can also talk about blockchain as a distributed ledger. Distributed ledger in that you don't have a centralized ledger, or rather a centralized block that carries or actually forms these particular blocks. So these particular blocks of transactions are what we refer to as the ledger. So we can also look at blockchain as a technology that is implemented on top of a particular network architecture known as peer-to-peer. For us, for you, you need to understand maybe what are some of the advantages and disadvantages of a peer-to-peer network. So one advantage of a peer-to-peer network is that it gives the opportunity of a particular computer, or rather a node, to either be a client and server. So any computer can be able to perform these particular functions, and that is what is adding to the advantages of a blockchain. So all these particular nodes, or other computers that are connected to form blocks or chains, have the mandate to either respond to requests, or rather to request some kind of functions from other nodes without really having a centralized server. So when we talk about blockchain technology, we do away with the client-server architecture and we bring on board the peer-to-peer kind of system. And of course, we also can refer to this particular ledger as a distributed database. We are going to look at, maybe in our next lesson, the difference between a distributed ledger and a distributed database. There are some kind of unique differences that we need to understand. So just to wrap up what blockchain is all about, you need to understand that currently the most successful implemented application or other technology is actually Bitcoin that uses blockchain. So normally it contains financial transactions. Also need to understand that most of these particular transactions are replicated, right? They are replicated across the different nodes. So that means every particular participating node is actually a device that is connected to a network, must have a copy of these particular transactions, right? And of course, before a particular block is validated, there must be some kind of digital signatures and hash functions that needs to be appended to it, so that it proves some kind of identity and authenticity to that particular block. We are going to see how blockchains or these particular blocks are formed. Again, also you need to understand that blockchain technology has different types, or they're written in different types. We have public blockchains, we have private blockchains, right? And of course, we have hybrid blockchains. All these particular blockchains are implemented. So a private blockchain actually is limited only to some given organization or function, whereas public blockchain is available for anyone who wants to join that particular chain. The other advantage of using a blockchain is that it can be read by participants, often across a wider environment. Like for example, you can have the technology being implemented in Africa, but actually it has also some kind of participating nodes from across other continents. So different people can be part of this particular blockchain. So as you can see here, ideally this is just chain of blocks, right? So once a particular block has been formed, it gets validated by the different nodes, and then it allows the other participating nodes to create a different block. So we can always form different chains of blocks. So ideally, the blockchain has been there for a while, right? And for you to understand what a blockchain technology is, you need to really understand ideally how peer-to-peer systems work. And of course, you need also to understand how the internet also works, because internet has different protocols that allows the blockchain to function, right? We talk about TCP protocol, we talk about the UDP protocol, and so on. So it has been there for a while, but it adds a value to the internet. That's why we need to really understand how this particular blockchain technology function. The feature that it adds is the trust layer. So far, we have understood that we have e-commerce systems that are secure, but people don't trust maybe doing some transactions online. So by use of blockchain, people can actually have some confidence in actually purchasing online using their credit cards, right, without really fearing of someone hacking into those particular systems. So that's a great advantage, the security aspect, and actually also the trust functionality that this particular blockchain technology brings on board. So the first blockchain technology was tested in the year 2009, and that is the cryptocurrency known as Bitcoin, right? So over time, people have been researching on how we can come up with additional applications that can actually use this particular technology, right? So when we talk about blockchain, we bring in the concept of decentralized systems. So whatever runs on top of blockchain, or whatever application that uses blockchain, must be decentralized. I'll give you a practical example. For instance, if for instance you want to share a Bitcoin across multiple nodes, right? Every transaction, when you initiate a transaction, every participating node has to have a share of what you are trying to maybe pass across this particular node. So the transparency aspect of a blockchain also gives it an advantage over other technology. So every node has a copy of those particular transactions. So it creates some kind of transparency. So you can see from this particular diagram, of course, we have secure systems, and the blockchain adds the trust layer that I've so far talked about. So for most of us who are developing websites, we can actually factor in this particular trust functionality from the blockchain, so that we enforce security and other elements of blockchain. So you can see it has really changed how we can use the internet. In fact, the greatest advantage that it has brought to the internet is that particular trust layer. So you don't really need to have issues, right, with security, with the transparency and everything, unlike nowadays. So everything that we do across the internet, or or everything that we do online, if they run on top of blockchain, then you are rest assured of this particular security and trust levels that you're talking about. So blockchain is just not a technology that is used by Bitcoin, but other application can use it. It is a public ledger system, or what we refer to as a distributed ledger system, that you're going to see. So it's very, very important to understand how a particular blockchain is formed. Like you can see here, a block is actually, the first block was created by the inventor, right? But that is Nakamoto, and you have always gotten other additional blocks, right? So each time a block gets validated, a new block is generated. So we can have different blockchains, or rather blocks, being created after validation has taken place. Also, we need to know the technologies, the underlying technologies that forms a blockchain. I've so far mentioned about cryptography, right? The use of these particular secure mechanisms, such as digital signatures, the keys, right? When you are participating in a blockchain, one node has to issue a public key and also remain with a private key, just for security purpose, right? And of course, we have also mentioned the P2P network. I'm going to explain in details how this peer-to-peer network contributes into the formation of a blockchain. And of course, the blockchain needs a program, right? So the good thing is that blockchain can be created using different languages. And more so, we also need to understand the consensus algorithm that creates some defined protocol that gives the guideline on how communication needs to take place within the chains of a block. So you can see this particular diagram showing some kind of centralized system that is being eradicated by use of the blockchain technology. So the right side, we see a decentralized infrastructure, right, where people can actually, and even organization, can share their, it could be their finance, or rather it could be the application, it could be government processes, can be shared across multiple nodes or within different locations. So these are decentralized system that is brought about by the use of blockchain. So in summary, ladies and gentlemen, we can say that a blockchain is actually the use of mathematics to create a secure distributed ledger which enables transaction, right, that doesn't really rely on third parties, right? So What we really mean here is that when you say use of mathematics, when you're mining bitcoins, for example, the computers, or rather the miners, need to use a lot of computation to find the right keys so that they can be able to maybe get some kind of reward or something, or rather validate the block. So that's where the mathematics comes in. Security is brought about by the concept of using digital signatures, or what we have seen as cryptography, and of course distributed ledger. A ledger, we have said, comprises of multiple transactions that are replicated across the network, and it eliminates the centralized server. So every participating node has a copy of this particular ledger, and we don't need a central mechanism. Let's take an example of a bank. If you want to maybe transfer funds from one person to the other, you need to have a third party. It could be a bank, it could be a PayPal, right? So these particular centralized third party systems are eradicated using a blockchain. So I think that is a clear picture of what blockchain is and technology. So let's look at maybe the foundations, or rather the technology that brings on board this particular blockchain. That is the blockchain structure. So the blockchain structure here, we have said we are using the P2P. We are not using the client server, right? A peer-to-peer architecture is what is used in a blockchain. And you can see from this particular diagram, a blockchain eradicates what we refer to as the third party. The third party, it could be an application, it could be an organization, right, that sits across either the nodes or people who are communicating. Now, the peer-to-peer architecture is what is being embraced. As you can see from this particular diagram, different nodes are replicated, or we have different nodes from different locations. These particular nodes actually comprises of different blocks of transactions, right? And you can see we have participating users, the pseudonymous clans, who have their unique keys, right? And they can always initiate the transaction, and some other users can be able to validate those particular transactions, and the block keep on growing, and the number of nodes keep on growing. So you can see a block structure, the way it looks like, or a data structure. It comprises of the hash function. Hash function is actually some kind of mixed characters that are very unique in each and every block. So anything, ideally what we need to understand by this data structure of a blockchain is that it has the unique hash functions, and each and every block that is formed must comprise of the previous hash function from the block that was created before, so that when you want to kind of hack the blockchain or the data structure, it will be very difficult. And that's why hacking a blockchain structure is very, very difficult, because you need to have all these hash functions or hash numbers from different blocks. Ideally, hacking a blockchain is not that easy. You need to have like 50 plus 1, right? Information about these particular blocks. So if there are 10 nodes, you need to have like, or convince 6 users, right, participating on those particular nodes to be able to give you these particular hash functions. And better still, there's the nonce. Nonce is a unique number that this particular data structure of the block should have. The additional information that is not actually captured here, which I'll be talking about later on in our next lesson. So apart from the block structure that you apart from the data structure, also we need to know the programs that you can use to create your own blockchain, or how the blockchains are implemented. So normally we prefer that use Solidity. Solidity is mostly a very high level language such as JavaScript. You can use even Node JavaScript to create your sample blockchain. So it's a very nice language. I'll recommend that if you want to create your own blockchain program, you can always learn about Solidity. So you can see the chain of blocks, or the blocks of data are used by the solidity, so you can always run and see which kind of blocks of data is being presented. I'd mention that a blockchain relies on the distributed system. So if you understand the characteristics of a distributed system, then you can as well understand the characteristics of a blockchain. First, we have looked at transparency. A blockchain technology, or if you implement any application or other technology that uses a blockchain, it provides some kind of transparency. And that is true to any given distributed system. Openness is created, as we have seen, when a particular transaction is formed, right? Everyone needs to understand, right? So this particular broadcasting of transactions across multiple nodes actually also brings about openness. Another characteristics of blockchain technology is what we refer to as security. We have seen how secure a blockchain is, the use of cryptography, and of course scalability. It allows additional blocks to be formed as time goes, or as you get validated. Blockchain also has a way or internal mechanism of handling a failure in what we refer to as forking. So if maybe there's some kind of disagreement between the forming nodes, right, about how to validate a particular block, they can always go separate ways, and then there's some kind of negotiations that has to happen. So forking is actually creating different blockchain. Then at some point they'll need to validate those particular blockchain and see which blockchain are used. That is what we refer to as forking. Then concurrency is also another advantage, right? You can always create this particular multiple. You can replicate this particular transactions in a concurrent manner without any issues. So take these characteristics of a distributed system and place them within a blockchain system, because they are more or less the same. Also, you need to understand that since a blockchain technology relies on a distributed system, then we need to understand how transparency is brought about. So transparency can be brought about by having the distributed operating system implemented across the multiple nodes that are there. So you can see from this particular diagram, we have the nodes. These are the machine A, machine B, and machine C, and even up to machine X. So the distributed application, where we have distributed applications, that's where the blockchain is actually implemented. So with a distributed operating system, we can always run this particular blockchain on top of the underlying infrastructure smoothly without having compatibility issues and so on. Just to add on top of this distributed operating system, also you need to understand the middleware, right? So it's not a must that every node that you are using maybe to implement this particular blockchain to understand each other, or to know the various hardware and software infrastructure, right? So every participating node should actually think that they are the same, right? So if one is running a different operating system, the other one is running on a different operating system, they need to really converge and understand that they are operating within the same environment. And this is what's bringing the transparency alive when you're using the blockchain technology. So I think I'm really trying to break down the underlying technology that the blockchain really uses. So why we need the middleware, as you can see, it first of all, you can see it creates transparency, as you have seen. It allows transactions across different nodes or other databases, right? Of course, it also allows the integration, right? It also allows running of different or multiple operating systems. I mean, there are many advantages of using the middleware when you're implementing a blockchain, so that someone might really, because someone might ask, what are these infrastructure that we need to have for a blockchain technology to be implemented? So when we talk about infrastructure, you need to look at the software part. You need to look at the hardware part. So there are a lot of things that we need to understand, but from the distributed systems understanding. So I've just given you some basic understanding of how this particular blockchain can be implemented. Again, we can't leave this particular understanding of what P2P systems are, right? So we have understood that blockchain technology is implemented in a peer-to-peer network, right? So as I'd mentioned, in a peer-to-peer network, all the nodes, all the computers are the same. That's why the peer-to-peer name comes from, right? So if a computer can be able to practice or actually undertake the task of a server, it can still be the same computer undertaking the task of a client. So it can either be a client or a server at the same time. So this eradicates the notion of a centralized server, right? You see, if you have a client server architecture, more functionality resides from the server end, which actually creates a lot of control at the center, which is eliminated by the P2P, right? So you can see can also be implemented within an overlay network, right? So an overlay network is a network that is implemented on top of other existing networks or infrastructure, right? So that is the good news with implementing a blockchain. You don't really need to reinvent the wheel or create the infrastructure from scratch. That's why you can say from the history of a blockchain, we can implement a trusted layer on top of the internet, right? So you don't need really to recreate anything. So you just need to create your program and you launch it on top of this particular network. So for those of us who don't understand how a peer-to-peer model looks like, there's no server between these particular nodes. So every computer or every node is free to communicate with each and every node. So there's a high level of transparency, and all these particular tasks that are being executed across these nodes are more or less the same. So there's no node that has maybe privilege of executing additional duties. But maybe I'll bring on board the issue of miners or mining. The nodes that mines this particular, for example, bitcoins, kind of have some advanced processing mechanism, because there are a lot of mathematical computation that needs to be done. This shows a purely decentralized P2P, right? And as a matter of fact, any technology normally has some down and ups. So you can realize that, of course, the peer-to-peer network also has or can run into problems. Maybe we can talk about communication overhead, manageability of this particular communication, security, how consistent is data, right? So all these, when you implement a very good blockchain, can be eliminated, right? So we don't have a central coordination of activity. I think this is what blockchain seeks or seek to remove, right? This form of centralizing resources is what is a game changer of blockchain. It doesn't really allow centralization, right? Ideally, also it offers flexibility when you have this particular P2P network. As you can see, you can run different applications within the application layer, right? So it also factors in the different flexibility of topologies that you can have. We have different protocols that can also be used. I'll mention about the TCP, UDP, right? And even the ICMP, right? So everything here creates some kind of transparency. So what are the properties, the key properties of a P2P network that makes it conducive to implement a blockchain technology? One, scalability. Second, there's no single point of failure, yeah, because of this particular replication, or rather distribution of transactions across multiple nodes eradicates this particular centralization of activities. There's resilience to denial of service. More so if there's some kind of attack, maybe a hacker is trying to use some malicious softwares, it can always maybe eradicate that. There's some very nice load distribution across the various nodes. So each and every node has its roles that it plays, and of course there's resistance to censorship. There's no any particular role for a given node. Every node that participates in this particular chain of blocks has equal mandate. So in summary, the blockchain is all about decentralization. That is very key. It's all about disintermediation, right? Removal of intermediate features. It's about distributing immutable ledger. What we refer to as immutable ledger is actually a ledger that cannot be altered or changed easily, right? Once it has been validated by more than 50 plus 1 nodes, then you can't be able to change it, right? And of course, it has grown with the time. About security, we have talked about cryptography, and it enables accuracy and so on. So to finish this particular introduction to what a blockchain is, we need to understand why we need to care, right, about blockchain, right? Because the need of this particular technology is growing every day and night. Most organizations that have implemented this particular technology, as you can see, have realized that they can solve problems, they can design different solutions using a blockchain. So it is your chance to really do some research if you are interested in blockchains, to understand maybe how you can work around a given platform that's going to provide some solution to different industries. It could be healthcare, it could be transport industry, it could be hospitality, and so on. So these are just few enterprises that have implemented blockchain technology, and you can see with time additional enterprises will come on board. So that is all about introduction to blockchain. So you can always hang around so that you get more information about this particular topic. All right, thanks.